Hello, everybody. Thanks for joining us. My name is Mark Lockpeeler. I'm with the Technical Alliances team here at MemSQL, and I'm joined today with Ramon Lopez, a Sisense solutions engineer. We're excited to walk through for you operationalizing analytics using MemSQL and Sisense. As an introduction to today's topic and our workshop and demo, we wanted to talk to you about why organizations are leveraging analytics from an operational perspective. Why operationalize machine learning? And here are some of the reasons that organizations are doing this. Predictive maintenance through anomaly detection. Examples here are proactive airline maintenance, reducing manufacturing downtime. Cross-sell and upsell, where we're trying to increase sales for retail e-commerce. Personalization to improve customized website experience, and also improved customer service. The bottom line is operational analytics can save major organizations millions of dollars if done right. For today's demo, we're going to actually use live New York City taxicab event streams. We're going to be running analytics inside the MemSQL database. We're going to be scoring each streaming event using a deployed machine learning library. And in addition to that, we'll be leveraging Kafka, S3, SageMaker, and also Sisense. And MemSQL will be at the heart here as the always-on de facto standard data and analytics store. So let's get started. Let's first share with you. So just to emphasize what you're going to see today, we're going to, again, be bringing live data off of a Kafka stream into MemSQL. As that data is being ingested, we'll be using a SageMaker RESTful API endpoint, and we will score events as they stream into MemSQL. Those events will then be displayed on a real-time dashboard using Sisense. And we also have the ability to do alerting to operational teams in the case of anomalies. So Ramon, could you talk to the audience about what you're going to be showing today?
Not know, Sisense is an end-to-end business intelligence and analytics solution that we're using in this scenario to take advantage of the MemSQL database, the data that's being ingested and streamed, as well as being outputted by SageMaker to create very beautiful, interactive, and insightful dashboards for analyzing the data. At the end of the session, I'll be doing a quick demonstration and digging into some of the details as to how we built what we built and the benefits of the dashboard at the end of the day.
So now that you have a high-level understanding of what we're going to walk through in this workshop, let's go ahead and build the operational analytics environment. First thing we're going to do is I'm going to jump in and create a database and the pipelines needed to ingest the initial step 1 data from Kafka and S3. Then we're going to use MemSQL stored procedures to deploy real-time analytics into the database. We'll then jump over to SageMaker and we'll build, train, and deploy a machine learning model. From there, we'll actually operationalize that model using MemSQL pipelines. Then we'll bring it all together and Ramon will show you how to operationalize a dashboard using Sisense and MemSQL. So before we get started, just so you know, we'll be sharing with you the GitHub at the end of this session so that you can actually try it yourself. So without further ado, let's get started. Again, the first step is to jump into MemSQL, create the tables inside of a new database, and then create MemSQL pipelines to bring in our initial set of data. So let's tell you about that data that we're going to bring in this first step. We have a Kafka instance deployed, and that Kafka instance will be leveraging 2 public topics. The first one is drivers, and the second one is trips. We'll also leverage an S3 bucket in which we have neighborhood data. So let's talk about a sample of this data. First, we have the trips event. This event has an ID for every trip, the current state of the trip. In this case, we're in the requested state. We're not actually in our taxi, but we do know the geolocation of the passenger with some additional data associated with that. The driver event actually has a driver ID, the name of the driver, the current state of the driver, and also the geolocation and some additional data. Now, both of these sample events are being generated live using a simulation of data that you could find inside of the New York City Taxi Limo and Commission Yellow Taxi Trip dataset. This dataset is a public dataset, and we have actually created a data generator to generate these live feeds and send them as a producer into Kafka. We will actually then be pulling the neighborhood data out of S3. And here's a sample. Jamaica Queens neighborhood has an ID associated with it, and it's will be stored in MemSQL as a polygon. So we'll bring in all of the neighborhoods from the New York metro region and store them in a one-time pull from S3. So let's jump into MemSQL Studio and show you some of the code we're using today to create our demo. All the code that we're working from today, you'll be able to find in the GitHub referenced here. So we just wanted to make sure you knew that was available. There's some great step-by-step guides in the README and presentation. So you should be able to do everything we do here today yourself. Now, the first thing I wanted to show you was the tables that we created for step one. And you can see here we're creating a New York City taxi database. We'll create the drivers table, the neighborhoods table, the trips table, and other tables that will support our visualization, including a NAB New York City taxi scored table. It has a timestamp, the number of riders, and an anomaly score. And we'll explain this one later. So let's actually show you the pipelines also that we created in step one. As we mentioned, the first one is the drivers topic coming off of Kafka. The second one is trips. These are public Kafka endpoints again. The third one is stored in S3 on AWS. And to start up our pipelines, we just run the start pipeline command as shown here. Now that we've got the database and tables set up and our initial pipelines, let's show you how to deploy stored procedure within MemSQL to run advanced math. And we call this in-database scoring. We're able to create user-defined functions, stored procedures, user-defined aggregates, arrays, records, and control structures. And when we combine that with ANSI standard SQL, we can create very powerful scoring models in database. So let's go and check this database tab out. We've got our New York City Taxi database available. We come up here, we can see our pipelines are running. Let's go ahead and show you a in-database stored procedure that we want to build, and we'll just go show you that from the GitHub. So this is a prototype, so we're doing some cleanup up front, and then we run a number of analytic queries. Those analytic queries will run consistently as data is being streamed in, and we'll be collecting things like the total number of trips for each neighborhood, the average distance of a trip, etc. So there's lots of statistics that we'll be creating and running in real time while data is being ingested. That would be available for visualization later. Now that we've built a stored procedure and we've actually started it up, let's go ahead, build, train, and deploy a machine learning model. We'll actually, as we mentioned, be using SageMaker to do this. In the model algorithm that we selected is random cut forest. Now, this algorithm is designed to detect anomalous data points within a data set. And during the training phase of building this model, we'll actually be using the New York City taxi average ridership data set. We've actually stored it away, or a sample of it, in Amazon S3. So let's jump into SageMaker and build and then deploy this model so that we can use it in a subsequent step. Now that we have our random cut forest model deployed, we want to use it to score all data as it comes in. We want to use it to score each event as it's streamed in real time into MemSQL. So let's go ahead and jump into Jupyter and show you how we leverage SageMaker to build, train, and then deploy the model. Here we've selected the right project and started that up. And the first thing we do is we just point at the S3 bucket that we need to train our model against. So we do have a public bucket out there. So we'll need to run this, and we'll need to make sure that our S3 bucket's available, and it is. So then we'll actually go through and store that data into a Panda data frame. And now that we've got the data stored in a Panda data frame, let's go ahead and check out the first couple records to make sure that we have the timestamp every 30 minutes and the number of riders every 30 minutes. So we've got 6 months worth of data we'll train our data set on. Now, due to time, we've already run through a lot of data science visualization, making sure that our data is correct, just taking different slices and dices of the data, and then we train the model. And as I mentioned, we're actually using the random cut forest anomaly detection algorithm. We'll run this, train the model. Once the job's complete, we'll actually have a model available. But that's not only what we need. We need to deploy this random cut forest model out to an inference endpoint. And that's what we do with this step. And once we have it deployed, we can go over into Amazon SageMaker, and we can see that not only do we have a model, and here we have several, but we'll be using this model, but we also have an endpoint that now we can call from the MemSQL transform pipeline. So we're ready to go to step number 4. Now that we have our random cut forest model deployed, we want to use it to score each event as it's streamed in real time into MemSQL. So let's just give you a little bit of background on that. The data set that we're using is the Numenta Anomaly Benchmark NAB New York City Taxi data set. And that data set has 2 fields. It has a timestamp and the number of riders every 30 minutes. And what we want to be able to do is pass those 2 values into our model as the data streams through, and we want to be able to output the 2 fields plus the anomaly score. And we accomplish this with transforms within MemSQL. For this particular transform, we happen to be using Python. But within MemSQL, you can use Python or any executable that can process standard in and generate standard out in the correct format. In this case, you can see that Python script will actually call the SageMaker runtime and invoke the model for every event that comes through. The way we add this to our create pipeline statement is we just add the with transform clause and point to the location where the Python script is stored. It will actually run the transform on every leaf, and every leaf will then pass events over to the SageMaker model that's been deployed to score the record. We could also choose to score in batches, and we could also choose to score additional model endpoints, and both of those are optimizations. So let's actually show you the Python transform code called score riders. Remember, this is a prototype, and we're scoring each record against a SageMaker endpoint. In production, you may want to score in batch. You may want to also set up multiple endpoints, as I mentioned. But if we look through here, we need to insert the model here at this point. And we also need to pay attention to AWS security. Down here we have 3 values we need to set for AWS's security, if that's set in your environment. And basically, here is where we call SageMaker, and the model name gets injected, and we score each record. In addition to this, let's take a look at the pipeline that we create to actually run this transform. So you can see that the pipeline has, as we mentioned, the extra clause with transform. So once we get that all running, let's go ahead and take a look at the results in our table. We can do that by simply going into the database and actually selecting from the NAB, New York City Taxi Scored table. And the results should come back, as we mentioned, with an additional field into the table. And remember, the only thing coming into the pipeline was the time ID every 30 minutes and the total number of riders every 30 minutes. The anomaly score was derived on the fly using the SageMaker endpoint. Now that we've got everything running, we've actually deployed our machine learning model. We actually want to add visualization, so I'd like to turn this over to Ramon to finish out this demo.
So here we have a Sisense dashboard. This is our opportunity to fully operationalize the data that is being piped into MemSQL. And I just want to first, at a high level, cover some of the fundamental functionality that we get from Sisense dashboards. And it comes down to slicing and dicing and being able to drill down into whichever data we want. So at a high level, we have a dashboard here with a variety of widgets, whether it's this indicator type widget that's giving us some high level important KPIs. We have a map showing us each one of the riders by latitude and longitude, and some pivot table and some other charts that are giving us some other perspective on our data. In terms of the interactivity, it's as simple as clicking on one of the pieces of the pie or clicking on a row on a pivot table. But let's say I want to focus on the borough of Brooklyn. I can left click on Brooklyn and see how my dashboard is going to refresh to show me data only for the borough of Brooklyn. This is all happening in real time. We're running different queries, filtering every single one of these visualizations to give us data only for the borough of Brooklyn. That's what drives the interactivity, is being able to slice and dice the data. The next component of interactivity I wanted to cover was being able to drill down into the data. So let's say we're looking at Brooklyn and we want to maybe focus on a specific neighborhood within Brooklyn. I can drill down in the pivot table right here where it says Brooklyn and select name for the neighborhood name. And it's going to give me now all those metrics, trips, average distance, price, etc., broken down by borough by neighborhood name within the borough of Brooklyn. You'll see how it's loading right now. It's a lot of detail that's being calculated. Once it finishes, the pivot table will give us extra information that we can use to continue slicing and dicing the data. There we see the details for all the different neighborhoods, and let's say I want to sort it by the neighborhood with the most revenue. I can go ahead and sort my pivot table and take a look and see that Williamsburg, no surprise, is the neighborhood with the most revenue. I used to live there many years ago. Now, how is this all made? How is this all built? How is this all powered? So what happens is that based on the data that's being streamed into MemSQL, we're building an analytical model on top of it that's going to allow a dashboard designer as well as a dashboard consumer to have complete freedom in the self-service UI to build out their own analytics, exploring that data and getting the insights that they need. We'll go ahead and take a quick peek at what that model looks like. So I'll go ahead and open up the data tab within Sisense. And you'll see here that we have, it's a very simple model in a sense. We have 4 tables. Now, these are not the raw tables that are being stored into MemSQL. I'm actually applying additional logic and cleansing. So the Sisense analytical model will serve as a semantic layer, as well as a layer where we can add additional logic. This additional logic is being added using SQL as its core syntax. And a simple example of it, I have a drivers table that's giving me information on first name, last name, and other details about the driver, but I don't have a column for full name. So what I do is I write a little bit of custom SQL here to not only give me the driver information, but also concatenate the first name and the last name to give me a nice pretty string that I can use in my analysis. The syntax that I'm using here is MemSQL standard syntax, MemSQL functions. Another example of that is the geodata. So I'm leveraging the geography intersects function within MemSQL to extrapolate based on a latitude and longitude what neighborhood and what borough the individual pickups from the taxi rides were. As you saw on the dashboard, we were looking at a map with lats longs. As I filtered on a borough, it would filter those latitudes and longitudes. This function is what was powering that. One of the key things that I want to highlight is that once the data pipelines in MemSQL are built, and once the SageMaker integration is built, there is no need to actually do additional modification to the MemSQL database or to the data pipelines. The analysts can then be independent from the database administrators in terms of doing their own analysis on top of that data that's already being piped into the data set. So now that we've seen how the data model is built and what we can do to the data that's in MemSQL to support our analytics, I'm going to go back to our dashboard. I'm going to highlight 2 additional concepts. First of all, is we talked about operationalizing your dashboards. When you have a dashboard in the Sisense application, it's shareable, distributable, and it supports collaboration throughout the organization. So you can go ahead and distribute it through to whoever needs it, as well as potentially embed it within your own applications if it's an OEM capacity situation. The other thing that I want to highlight is the fact that we can do subscriptions to the dashboards. You can do natural language querying to support being able to ask questions out of the data. And finally, we can do alerting. So you can create alerts on specific KPIs that you want to keep track of over time to make sure that whenever that alert the threshold is broken or potentially an anomalous figure is being recorded, you'll be able to send a notification through your mobile iOS or Android apps or via email to go ahead and take a look at that number, look at the dashboard and see what's happening there. And finally, the last point I wanted to make was the fact that we're not aggregating the data. We're not summarizing the information. We actually have all the detail that you would need. We're looking at very nice high-level KPIs. But let's say, continuing in our Brooklyn example here, we're looking at the borough of Brooklyn over this period of time, and we see that drivers, the top 10 drivers that have the most rides. Let's say we want to focus on the top driver, Emma Taylor. I can simply select Emma Taylor. It's going to add another dashboard filter, and it's going to filter the whole dashboard to give me information only for Emma's rides. So the key point here is that we're not aggregating, we're not working with summarized information. We're querying in real time the raw data, and this is all possible because of the compute power supported by MemSQL, as well as the ease of use and simplicity of the analytical dashboards within Sisense. So at a high level, Sisense is, like I mentioned, a full stack or single stack business intelligence analytics solution that's supporting the organization in 3 different core ways. The first one is through our cloud data teams product that is a code-driven tool that supports analyzing cloud data sources and delivering advanced data insights. This has functionality that supports whether it's ad hoc research, notebook type, behavior using R and Python, or even having the capacity with cloud data warehouses to create materialized views. It's a fantastic tool based on an acquisition of a company called Periscope Data that supports developers and engineers that are looking to write code to work with their data. The second product is a Sisense for BI and analytics teams, which is pretty much what we looked at in the demo. And this is a self-serve BI application that supports organizations building analytical models and building dashboards that are distributable through the organization and explorable and simple to use. And finally, we're able to take those two products and make it for product teams. This is a scenario where you have embedded analytics within your own product, call it OEM, where you want to take Sisense charts and make it look and feel like if they were part of your native application. At a high level, here we're looking at the architecture diagram for Sisense, and one of the things that I want to cover is the infrastructure that's supporting Sisense. So Sisense is a Linux containerized microservices-based infrastructure leveraging Kubernetes, providing for a very dynamic and scalable and robust architecture that's going to support and fit very well into any cloud infrastructure out there, whether it's AWS or on your own on-premise cloud. And then in terms of the workflow, we have the capacity of connecting to pretty much any data source. In this case, we're talking about connecting to MemSQL, but we can connect to other databases, flat files, as well as web applications. And we have the ability of creating cached accelerated models or live models. In this case, we're doing a live model because we're leveraging the compute power of the amazing MemSQL. And ultimately, we end up with a web-based analytical service that supports and allows business users as well as analysts to create very rich and insightful dashboards. We have AI throughout the application, supporting whether it's analytics or data modeling, and we're also able to customize the application entirely to support the ability of running anywhere. We can run on a desktop, on a mobile device, as well as integrations with IoT devices like Alexas and smart light bulbs. Sisense is extremely extendable, and this is supported a rich API ecosystem that allows developers and IT managers to completely customize and automate any process that is required to operate the application within your environment, whether it's working with data models, whether it's using JavaScript and the modifying the UI, as well as management and SDKs for deploying and maintaining your environment.
Ramon, thank you so much for sharing with us the power of Sisense, MemSQL, and AWS together, creating a modern cloud-native data stack for operational analytics. So where can you get more detail? We actually will be running AWS Dev Days near you, so please check with our business teams. I hope you found this information valuable. Thanks for listening.